Welcome back. I'm here in our default map, and you may have noticed that I started using the default map in the previous few videos, and that's because it's nice and open, it's got a lot of room to run in, and it's well lit, so it's easy to see the things that we're developing. Now, we may go back and forth between different maps to see different lighting and obstacles and different things like that and how they interact with our character. But for now, I'm going to be using this default map for some of the videos. Now, in the previous videos, we've been working on some of the animation aspects to our character. For example, we've got our turn in place, which looks really nice. And we also have our aim offset, which allows us to point the gun in the correct direction, and it looks really good. Now, a common gameplay mechanic that you see in lots of games is leaning. When you run, our Bellica character stays upright, so it doesn't really look very natural. But if she were to lean when she turns, it would look a lot more natural because when you're running and when you turn while you're running, you have to lean to keep your balance. So we're going to add a lean mechanic in this video. So let's go ahead and get started. So I'm here in Shooter Anim instance. And you'll see that I've created a character yaw and a character yaw last frame. And these are used in our turn in place function in order to get the delta between last frame and this frame for the character's yaw. But you'll see in the turn in place function that we're not updating these while the speed is greater than 0. So when the character's running, we're not actually getting that delta between last frame and this frame for the character's yaw. And so for that reason, this character yaw and character yaw last frame are really only good for our turn in place animations. So if we want a character yaw and a character yaw last frame for leaning while we're running, we're going to need a new set of float variables. Now, in order to distinguish between which one is which, we might as well go ahead and rename this character yaw and character yaw last frame so that we know that it pertains to the turn in place mechanic. So we might as well just put TIP for turn in place at the beginning of character yaw and character yaw last frame. Now, if we do this here in shooter_anim_instance.h, we have to do it in shooter_anim_instance.cpp everywhere we use those variables. What I'd like to do is just highlight turn in place, the entire function, and I can do a Control-Shift-F, and you'll see it says find and replace. And if I click on replace in files, here for find, I can type character yaw. And for the replace, I can type TIP character yaw. We do want to match the case. We do want to match the whole word. And here where it says look in, it's asking if we want to use the entire solution. We don't want to replace things in the entire solution. We only want to replace character yaw with TIP character yaw in the current document. So if we select current document, now we have the option to choose current selection, and that's what we have selected. Now if we click replace all, it says 5 occurrences replaced. Click OK and click the X. And now let's make sure that all we've replaced is the character yaw with TIP character yaw. And that's what it looks like. Here we have an instance here, here, and of course if you highlight a variable, then Visual Studio will show you the other variables with that same name. Let's go ahead and do the same thing for character yaw last frame. So I'm going to go ahead and highlight the whole function, and I will Control-Shift-F, and here I have replace in files character yaw. I can change this to character yaw last frame. And for the replace, I'm going to put character yaw last frame with TIP in the front. Now we're going to match case, match whole word, current document, and current selection. And we'll click replace all. And it says 3 occurrences replaced. So that will take care of changing the name of character yaw and character yaw last frame. Now the reason we're going through all this trouble is because we want to have character yaw and character yaw last frame for our character, and we want this to be updated every frame regardless of whether we're running or not. We're going to use it while we're running. So down below all our variables, down at the bottom of our public section, we're going to create a float called character yaw. And we're going to create another float called character yaw last frame. Now we're going to give these some comments. And for character yaw, I'll say character yaw this frame. And for character yaw last frame, I'm just going to say character yaw last frame. And for TIP character yaw, I'm going to add to the comment here, because it says yaw of the character this frame, I'm going to say only updated when standing still. And in fact, if you look in turn in place, we're also updating it if we're not in the air as well. So we're going to say only updated when standing still and not in air. And I'll copy this and I'll add this to the comment for TIP character yaw last frame. So we have character yaw and character yaw last frame. Now for our character yaw and character yaw last frame, we're going to want to update these every frame. And this will be used for our leaning, so we're going to create another function similar to turn in place, and we're going to call this function lean. So it's going to be void, and we're going to call this lean. Now I'll give this a comment, and we'll say handle calculations for leaning while running. And I'll go ahead and give this function a function body. So here's our lean function. For our lean function, we're going to get a yaw delta. We're basically going to get the difference between the yaw last frame and the yaw this frame. So of course that means we're going to update our character yaw. So we need to check to see if shooter character is null. So if it's null pointer, then we'll return out of the function. And of course we're going to update our character yaw. So character yaw equals shooter character get actor rotation dot yaw. And before we update character yaw, we can set character yaw last frame. And we're setting that to character yaw. So this gives us our character yaw last frame in this frame, and we can get our character yaw delta. Now our yaw delta is something that we'll use in our blend space for running. So we're going to add a new float variable for the yaw delta, and we want to expose this to blueprints. So let's make a float called yaw delta, and let's give this a U property, and let's make this visible anywhere, blueprint read write, and the category will be lean. We'll make this meta equals allow private access equals true. And for the comment, I'm going to say yaw delta used for leaning in the running blend space. Now here's how we're going to calculate yaw delta. It's not going to be simply the delta between frames. We're going to use that, but we're also going to be using interpolation here because we want our lean to be smooth. So since we're going to be using interpolation, lean is going to be needing a delta time. So let's change our lean function. We'll go back up here to where we declared it, and we'll add float delta time as an input parameter. And of course, we're going to need this in our function definition as well. So here's what we're going to do. We're going to make an interpolation target for our yaw delta. We're going to create a const float called target. And we're going to initialize target with the delta between this frame and last frame. So we're going to get character yaw minus character yaw last frame. Only we're going to take this value and we're going to divide by delta time. Now this may feel a bit odd dividing by delta time. Thus far we've been multiplying things by delta time, and this time we're dividing. So what's going on here? Well, the delta between last frame and this frame is the amount of yaw that has changed This gives us a measure of how quickly we're turning. So if we're running and our character's yaw is turning very rapidly, then yaw delta will be larger, which means we're going to want to lean more. Now, if we multiplied by delta time is a very small value, and that would make this value smaller. But we're dividing by a small value, which is going to make this bigger. So we're going to interpolate yaw delta to this target. So let's make another const float local variable and call this interp. And I'm going to initialize this using fmath finterp2. And so our current will be yaw delta. Our target will be target. Next we need delta time. And for the interp speed, I'm going to use a small value like 6.f. So this interpolates yaw delta towards target, which is yaw delta scaled by delta of time in a sense that it's larger. So we have our interp value, and we're going to set yaw delta equal to that. So yaw delta is equal to, and we're going to use interp, but we're going to clamp this between negative 90 and 90. So fmath clamp, and we're going to use interp negative 90.f and 90.f. So we can go ahead and get rid of the lines between those. And so that is going to take care of our yaw delta. Now, in order to see what yaw delta looks like, we can use a on-screen debug message. So we can check to see if we have a valid G-engine. And if so, we can say G-engine add on-screen debug message. Now, I believe we're already adding an on-screen debug message in turn in place using the key value 1, so we're going to use a different key value so we can see both of those. And for time to display, I'm going to use -1 because I'd like to see this displayed every frame and updated every frame. For the F color, I'm going to use an F color, and I'll go ahead and use cyan. And we need our message. So I'm going to use fstring's printf function to create a formatted string. So fstring printf. I'm going to use a text macro. And I'm going to say yaw delta. So yaw delta colon %f. Then after the text macro, but still inside the f string, I'm going to give yaw delta. So that's our on-screen debug message, and I'm going to put each input parameter on its own line so we can see this while I'm using a large font. So this way we'll see exactly what yaw delta looks like. Now we're going to want to call lean, so I'm going to copy this and I'm going to paste it inside of our call to update animation properties. So I'm going to go down to the bottom of it just after turn in place, and I'm going to call lean passing in delta time, just like this. So let's go ahead and compile this. Okay, so there's a compilation error, and it says here declaration of yaw delta hides class member on line 114, and here I'm declaring a local variable const float yaw delta. That's here in turn in place. And so since we're creating a yaw delta member variable, we need to change the name of this local variable here. And so I'm just going to go ahead and change the name of this local variable to tip yaw delta because this is going to be used for turning in place. So let's go ahead and change yaw delta in turn in place to tip yaw delta. Now I only use it here in the else statement, so I can go ahead and highlight else and do Control-Shift-F, replace in files and find yaw delta, and replace with tip yaw delta. And again, match case, match whole word, current document, and current selection, we can click replace all, and only one occurrence replaced. So it was only used once, so that takes care of that. So now we should be able to compile. Okay, so here we are in the editor. We're going to test play and just notice while I'm running, if I turn the mouse very slightly, yaw delta is going into the negative direction. And if I turn it very slightly to the right, it's going in the positive direction. If I jerk it really quickly, it maxes out at 90 or negative 90. So this is going to give us a measure of how quickly we're rotating, how quickly we're turning our mouse. And of course, this will work with the console controller as well. And it doesn't take very much for us to go all the way to the maximum. So this gives us a measure that we can use in a blend space for leaning. So we're going to be adding leaning functionality to our blend space in the next video. So we'll see you then.